Okay, hi, Assalamualaikum and good day everyone. So for this video, kita akan tengok amino acid and there are two subtopic. First, introduction, and the second one is chemical properties. The introduction to amino acid, so kita akan tengok how to draw the structure and how to give the naming according to IUPAC and define zeta ion and also isoelectric point. So dua ni istilah yang baru kamu dengar lah. And draw the structure of the given amino acid in acidic medium, in basic medium, and also at isoelectric point. So the introduction is amino acid, it possess ataupun dia mempunyai both. The first one is amino group di sini and carboxyl group di bahagian at each end. Okay, so satu hujung amino group, satu lagi hujung adalah carboxyl group. Okay, so there are 20 common amino acid yang kamu akan jumpa after this, and tak perlu hafal, you just need to be familiar. Yang penting kamu tahu cara untuk naming according to IUPAC, and from the IUPAC naming kamu boleh draw out the structure. Okay, so apa yang membezakan all these 20 amino acid adalah dia punya side chain. Okay, bahagian R group tu. Okay, so this part yang membezakan the 20 amino acid. So bahagian kiri, okay, so this is the NH2 amino group and this one is the right hand side carboxyl. Okay, kekal sama. Yang membezakan hanyalah side chain at this alpha carbon. So ini adalah your alpha carbon. Okay, so ini glycine is the simplest amino acid because the R here hanyalah hydrogen. So you can see ini nama common name dia adalah glycine and nama singkatan dia kita tulis gly and simbol dia G. Okay, so nanti kita akan tengok IUPAC nomenclature for each amino acid, some of the example, and sekarang ni I'll just want to introduce to you the 20 common amino acid. Okay, so ini the simplest amino acid which is glycine, and this is valine. So macam mana nak ingat valine? Dia berbentuk V begini. Okay, CH, CH3, CH3. Okay, so kalau kamu draw out the structure in skeletal, nampak dia V. And then next is leucine. So leucine you have CH2, CH, ada cabang begini, CH3. And next is isoleucine. So this is the side chain. So kalau kamu perasan all the amino side, amino group dengan carboxyl group ni sama aja. Yang berubah hanyalah at this part. Hanyalah dekat bahagian sini. Okay, so ini pun sama R group. So ini pun sama R group, dia sahaja yang berbeza. Okay, so this one is alanine. So alanine also a common amino acid yang selalu keluar dalam exam. Okay, alanine, glycine, valine, and this one is phenylalanine. So you have CH2 and then bonded to it ada benzene ring. So ini dia punya singkatan dia adalah PHE. Right, so next kita ada tyrosine. So this one we have tyrosine. And then kita ada proline. So proline ni dia unik sikit because your side chain here, okay, carbon bonded to this end. Okay, and then you have serine. Serine ni pun antara famous jugalah because it's just a simple amino acid. And then you have cysteine. Next you have trionene. Okay, so beza trionene dengan valine tadi. Valine tadi just now you have CH, CH3, sini pun CH3. Okay, so this trionene kamu ada OH at this side. Okay, next kita ada methionine. So ini yang membezakan. And next kita ada this asparagine and glutamine and tryptophan, aspartic acid. Okay, so kalau macam ni, you have ada dua kan, COH, COH. Okay, so macam mana kita nak tengok which one is the side chain? Okay, so back to the basic concept, cari dia punya alpha carbon. Okay, so alpha carbon tu mesti ada COH, ada amino group. Okay, so this is the alpha carbon. So inilah kamu punya R, which is the side chain. And then this is glutamic acid and lysine. You have histidine here. So that's all untuk 20 common amino acid. Okay. Okay, some amino acid yang ada additional COOH, macam tadi kita ada tengok, they are acidic amino acid. Okay, yang ada additional COOH. So kalaulah that amino acid dia ada extra nitrogen atom on the side chain. Okay, so dia mesti syarat dia on the side chain, dekat side chain tu. Okay, so dia adalah basic amino acid. Okay, so the rest of them adalah neutral amino acid. Okay, sebab both ada, you have amino part dengan COH part. So macam contoh this one, this valine. So valine ni adalah neutral amino acid lah. Okay, so contoh kalau basic, okay, so you have amino dengan COH. Okay, so kalau dekat kamu punya side chain tu ada nitrogen, this is basic amino acid. And then kalau kamu ada extra COH in your side chain, dekat side chain, so this is acidic. Okay, so now kita cuba tengok this example. Okay, so the first one, okay, dia back to the basic concept. Okay, sebab kita ada dekat sini amino dengan COH. So which one has the higher priority? Of course, COH lah, the highest priority of all. Okay, all the organic compound. So ini yang akan jadi carbon nombor 1. So this is the parent chain. So yang lain-lain tu akan jadi substituent. So the naming for this one will be 2-amino 4-methyl pentanoic acid. Okay, so kalau kamu tak tahu dia punya structure, it's okay as long as you can draw out the structure from the naming. Okay, so next kita ada, okay, ni dia punya parent chain. So this is your carbon number 1, number 2, number 3. Okay, so dia sampai sini je, carbon number 3. This one is considered as your substituent, which is benzene ring sebagai substituent kita panggil phenyl. So 3 carbon, which means this is propanoic acid, and you have amino here. Okay, so let's have a look at this example. Kalau glycine, okay, tadi kita dah tengok glycine, dia punya IUPAC nomenclature is amino ethanoic acid. So kalau alanine pula, okay, so carilah dia punya longest chain and identify the substituent. So you have 2-amino propanoic acid. And kalau valine, you have this one is, so ini ada CH. Okay, so this structure 1, 2, 3, 4. So ini adalah 2 amino 3 methyl butanoic acid sebab ada 4 carbon. Right, so next isoleucine. So this one is 1 2 3 4 5, and you have amino 2 amino 3 methyl. So ini methyl pentanoic acid. Now kita nak tengok apa tu zeta ion. Okay, so zeta ion, it is a molecule with positively charged group at one end and also negatively charged group at another end. So macam mana tu? And for your information, untuk amino acid to exist dalam keadaan neutral, it does not really possible lah, because this part adalah carboxylic acid. This COH dia bersifat acidic, and this part dia bersifat basic. Okay, so dia akan ada reaction between these two. So dia lebih stable untuk exist sebagai zeta ion. So macam mana terhasilnya this zeta ion? So you can see here, one end dekat bahagian COH ni, dia akan jadi negatively charged, COO minus, and then dekat bahagian NH2 dia akan jadi NH3 plus. Okay, so satu side negatively charged dan satu lagi side adalah positively charged. Okay, so macam mana kita boleh hasilkan this zeta ion? It is formed when you have this. Okay, so remember acid dia bersifat donate proton. Okay, so COH dia akan donate this H from COH ni. So dia akan donate to the NH2 part here. Okay, so base sifat dia adalah accept proton. Okay, so that is why this part COH dia donate proton, dia akan jadi COO minus, kurang dia punya hydrogen. So hydrogen ni pergi ke mana? Dia pergi dekat this part. Okay, so dia akan form NH3 plus. Alright, so kita boleh juga panggil dia sebagai dipolar ion. Okay, so zeta ion ni actually come from German word. So zeta ion means dipolar ion. So maksudnya dalam satu compound tu ada dua charge yang berbeza. Okay, so let's have a look macam mana kita nak tulis this structure of zeta ion. So basically you have your alpha carbon, tulis dulu alpha carbon, and your side chain. So R ni can be anything, so simple hydrogen. So dia boleh jadi CH, CH3, CH3. Okay, depends on your amino acid. Okay, so bahagian kanan, bahagian COOH tu, dia akan jadi C double bond O, O minus, ataupun kamu boleh tulis COO minus terus pun boleh. And the other end will be NH3 plus. Okay, so mesti tulis dia punya charges next to it. So ini milik oksigen, ini milik nitrogen. Okay, so kenapa dia positively charged here? Sebab you accept one extra proton. So kalau kamu kira dia punya formal charge 5 tolak 4, kamu dapat positive 1. Okay, so let's have a look at this example. Have CH3 as your side chain. So kita tulis dia punya zeta ion. Okay, so this part will be negatively charged and this end will be positively charged dekat nitrogen. So side chain tu tulis je sebiji sama. Let's have a look at valine. So untuk ini, this part COH akan jadi COO minus, and then dekat bahagian amino group dia akan jadi NH3 plus. bahagian karbon dekat tengah tu, betulkan tulis CH sahaja. Because of the dipolar nature of this amino acid, they have unusual properties such as high melting point, high solubility in water, but they has low solubility in organic solvents such as ethanol, diethyl ether, and this is because they can exist as zwitter ion and they are too polar to be soluble in those organic solvent. Okay, so zwitter ion ni bersifat amphoteric. So it can act as base in the presence of acid, and dia pula boleh bersifat acid bila dalam keadaan dalam solution base. Okay, so in simple words, okay, you can see here in acidic solution, zwitter ion tu dia akan act sebagai base sebab dia akan accept proton to yield a cation. Okay, tapi kalau dalam basic solution, dia akan lose a proton, so maksudnya dia akan menjadi acid lah, to form an anion. Okay, so kita akan tengok these two nanti later. Okay, so let's have a look if we have in acidic solution. Okay, so sebab zwitter ion ni dia bersifat amphoteric, dia boleh jadi base, dia boleh jadi acid. Okay, depends on the solution dalam tu. So this in acidic solution, this zwitter ion dia akan bersifat base, so dia akan accept proton to yield a cation. So apa yang jadi dalam acidic solution, acidic part ni yang akan bertindak. So dia akan react dengan kamu punya acid. Okay, so you akan dapat this part jadi COH. Okay, so you akan release water molecule. So apa yang tinggal hanyalah this part NH3+. There's no changes to this part. Okay, so sebab itulah tadi I mention about the product is be cation. Okay, so you akan yield a cation here. In other words, okay, soalan juga boleh cakap, if you decrease the pH by adding acid to the solution of amino acid, okay, so ini pun bermaksud dalam acidic in acidic solution. Okay, so apa yang akan jadi, di COO- akan react dengan your acid dalam your solution tu, so dia akan accept this hydrogen, one of the hydrogen from the acid, and dia akan form COOH. Okay, so now you only have cation, this part, ataupun positive ion lah, dia tak lagi sebagai zwitter ion bila dia dalam acidic ataupun basic medium lah. So now kita tengok in basic solution pula. So bila in basic solution, the zwitter ion, okay, so since since zwitter ion bersifat amphoteric, so kalau dalam basic solution, zwitter ion tu dia akan act sebagai acid. So acid, apa dia punya peranan? Dia akan lose a proton ataupun donate proton to form an ion. So kenapa an ion? Nanti kita tengok. So this part, sebab dalam basic solution dia akan menjadi acid. So acid dia yang akan mendonate ataupun lose proton. So this part, okay, one of the hydrogen akan didonate and akan bond with OH- from the basic medium. Okay, so you akan form this part, dia akan jadi NH2 and you akan release water molecule. So macam mana nak ingat? Okay, so this one tadi bila negatif, okay, so ingat negatif dia akan react dengan positif, different charge. Okay, so kamu akan tinggal with this positif sahaja. So takkanlah positif tiba-tiba react dengan this positif. Okay, so tak boleh lah. So another way to remember this thing pula, kalau dalam basic solution, kalau kamu susah nak ingat dia grab, so for basic solution pula, so you can see here positive, dia react dengan OH minus yang negative. So barulah boleh react together. So you akan form this part of your NH2 and then H2O molecule. Alright, so this part dekat COO minus remain unchanged, and that is why this is the only part yang masih lagi bercharge. So ini adalah negatively charged ion. Okay, so this product is no longer called as sweeter ion lah, because you only left with negative ion. Okay, soalan yang paling famous dalam past year, dia suka tanya tentang this isoelectronic point ataupun isoelectric point. Okay, PI. So basically PI ni adalah the pH of which the amino acid exists as its neutral form. Okay, maksudnya no net charge, and itu adalah dipanggil sebagai isoelectronic point ataupun isoelectric point, PI. Maksudnya amino acid tu berada dalam keadaan neutral. So neutral dekat sini dia tak bermaksud pH must be equal to 7. Tak. Dia depends lah on that pH for that amino acid tu. Sebab tu kita panggil sebagai PI. So it can be 5 PI dia. Okay, pH 5 or maybe pH 8, depends on that amino acid. Okay. So, apa maksudnya at PI tu? It means that concentration of sweeter ion is at its maximum. So, dia paling banyak exist sebagai sweeter ion. And, in other words, dia punya amount ataupun concentration of anions is equal, balance dengan concentration of the cations. And the net charge is 0. Okay, so let's have a look at this example. So normally soalan dia akan bagi in this form lah. So let's say dia bagi the PI of glycine is 6.1. So maksudnya at pH 6.1, so this glycine exists paling maksimum dia punya amount of sweeter ion ataupun dia punya concentration of cation is equal to the concentration of anion, ataupun in other words kita boleh cakap ini, there's no net charge between them. Alright, so soalan biasanya dia sambung dengan draw the structure of glycine. Ini glycine kamu with side chain dia hydrogen sahaja. So draw the structure of glycine at pH less than 6.1, maksudnya dalam acidic medium ataupun acidic solution. And B, draw the structure at pH more than 6.1, maksudnya it will be in basic solution. And also at pH 6.1, maksudnya dia minta tulis dia punya, lukis dia punya sweeter ion. Okay, so now this is the example. And so these are the answers. Okay, so untuk A, ini jawapan untuk A lah. So this in acidic medium, okay, you akan form cation. Okay, so kenapa? Refer balik to my explanation just now. Okay, so you akan form positively charged ion. Okay, so in pH more than 6.1, okay, you akan form negatively charged ion. So this is the structure. Okay, so kalau at pH equals to 6.1 ataupun soalan boleh tanya at PI. Okay, so the structure will be this sweeter ion. Okay, so you can give your answer directly. Right, so that's all untuk isoelectronic point.